It should not be that challenging. Notice it says x bar 1 minus x bar 2, and there should be two formulas right underneath the ones that we did on Monday. Okay, so what do you suspect I'm going to write in the first box? And what do you suspect I'm going to write in the second box? And then what do you suspect I'm going to write after the formula? Is meant for both, right? Okay. So go ahead and add that. I brought my Christmas stuff today. Mr. Tava got me a Squishmallow advent calendar, and this was last night's. He's so tiny, and he's got a little hat, and he's going to come everywhere with me. He's so cute, and he looks really startled all the time. He's like, "Where am I?" Okay, all right, so scooch that off to the side, please, and thank you. Okay, now shape. Notice there's 3 bullet points, and that's because there's 3 different possibilities. When you're, guys, please listen. When you're working with 2 populations. Okay, so the first bullet point is the most obvious. The shape is normal if both population distributions are normal. Okay, that means that if it says normal in the problem for both distributions, so you would look for it to say normal twice, then you can state that the shape is normal. And then you get to use normal CDF. But that's really the whole point of checking the shape, is making sure that you can use normal CDF. Okay, does this make sense to you guys? So if it says normal for both, it's normal, move on with life. Okay, also normal, it's an N. Shh. If both of the sample sizes are greater than or equal to 30, and then you say BLT applies. So if it says the first population distribution is right skewed or left skewed or bimodal or something weird, but the sample size is 40, you're good. Okay, third option. Third option, just because you're dealing with 2 populations, one of them might say normal and one of them might say skewed or something else, but still has its sample size greater than or equal to 30. You still get to say normal. Okay. And then did we say not or non before? Not. No. What did we say? Non-normal? Okay. If it doesn't satisfy any of those 3 things, then you just say non-normal. And you can't use normal CDF, so you can't find a probability, which is going to be very unlikely because they're going to want you to do the problem. So the only time that's going to come up really is if they're asking you about conditions themselves in the actual problem. Okay. Center is not really exciting. That's the formula here. So the mean of the dot plot should be the mean of the first population minus the mean of the second population. And do I need to go over again how, when we're talking about differences, the difference is calculated first, and then you plot that dot? It's not two dots on the dot plot, it's just, what, did you notice myself? Oh. Yeah. I was excited about them. They say Samantha on the bottom. Does anybody know why that? Yeah. Okay. So, I know, I feel like I must go over it again. So. Okay, so you have one population, you find the mean size of Squishmallows. You have a different population, which is probably much smaller if it's not Mrs. Talbot's house. Let's just say you have Mrs. Talbot's house and Mrs. Talbot's classroom, two separate populations of Squishmallows. And you take the mean size of a sample of Squishmallows from Mrs. Talbot's house, and then you take a mean size of Squishmallows from Mrs. Talbot's classroom, including the outlier. And then you subtract the two means and then you plot that one dot. So I really want to make sure you guys understand the subtraction happens first. Then you plot that dot, just like the proportions. I think I did some arm waving over here about that. What was that last week? Some flailing of five. Okay. Now, spread. What do you expect I'm going to write first here? You're getting the pattern. That's great. Okay. So this formula is a little. I have pretty much this entire yellow sheet memorized, but when I was making the chapter 7 test, I hadn't taught any of chapter 7 yet. And I was like, this was the one formula I was like, I really should look it up because I was talking myself into it being other things, but it's fine. And I want for my math people out there, just want to really quick relate it back to the one for one population. They just wanted to add them together. So they squared the whole thing, which got rid of the square root on the bottom. If that makes sense. So when you square the top and the bottom, then it looks like this. And then combine them and then put it all under a square root. Do you guys see what I'm saying? It doesn't matter because you have your yellow sheet and you're just going to look at that, but just for my math people. Okay. All right, you're going to have to send a representative over to get the box. Yeah. This is 1.5. But you see where this is on my page. I'm already at the middle because I don't I use up too much space. We were just discussing, I think you can fit it. The worst thing is gonna be the copy and paste deal. Or the cut and paste deal. Which is like, no. I didn't, I thought that. I don't know what I heard. I thought somebody like. I don't want to work on it, like I can't say this and then I'm supposed to work on that. We don't sell it anymore. What'd you ask? Oh my gosh, Cameron. I have to tell you an NHS thing. Yeah. Later. Okay. Later. Okay. There was a degree in my class between two people. Anyway. Okay, I want to know. I was like, okay. All right, so this is gonna follow exactly what you would expect, shape, center, spread, and then probability. At the very end, though, I'm going to give you what's called the interpretations challenge, which means I'm going to ask you to, in your groups, try to come up with the interpretation for the mean and the standard deviation on your own. I'm gonna give you like 5 minutes to try to talk it out, and then I'm gonna put up the perfect response. So just want to see, I want you guys to be able to come up with these without having to write them down on a note card every single time. So, okay. What is the shape of the sampling distribution? Which one of the bullet points did this one address? Bullet point 1, 2, or 3? 1. Excellent. Okay, so it says normal here. It says normal here. So you say normal. Both population distributions are normal. That's the easiest one, by the way. Okay, find the mean of the sampling distribution. Okay, so the mean, and I'm going to write these letters. So do you guys understand that this is large and this is medium? Did you notice the L and the M by chance? Okay, so this is telling you the direction of subtraction. It's telling you to do L first, then M. So the mean of X bar large minus X bar medium. I'm really hoping that this Coke Zero, by the way, coming out of these machines. Just saying, just saying. Okay, so the large one is 27. The medium one is 17. 10 ounces. Okay, now the directions here say calculate and interpret. We're going to only do the 10% condition and calculate here. And then on the other side, I'm going to ask you to interpret both of these two because I need you to be able to do it. Little birdies flying out of the nest. Besides, I believe you. After all that, you can at least get most of it. It might not be perfect, but you can get most of it. I have so much faith. If it makes you feel better, though, I wrote the perfect ones before you got here just to make sure that I had it perfect. So I get it. Okay, so I have to do the 10% condition for both. Okay, what's the first sample size? Large, 20? I figure that there's probably more than 200 large drinks coming out of this thing. There's probably more than 250 medium drinks coming out of this thing. I'm thinking those are reasonable. I don't know. Back in the day when I was your age, it wasn't like not cool to work at fast food places. So I worked at a fast food place and I could tell you I churned out more than 250 large and medium drinks. Okay. Standard deviation of large minus medium. Okay. Standard deviation of large. 0.8. Sample size of large. Plus standard deviation of medium. Sample size of medium. We should all take a minute and practice typing this in. hanging off by the calculators. It's got like a tag on it. Unless somebody stole it. I do have another one. Because of thefting children. What? Oh, okay, so plug this into the power strip. Yeah. Okay. Did you guys get 0.205? Okay, also, just because you're, hopefully analyzing stuff as you go, I think that's pretty darn good for a standard deviation when the center of the thing is 10 and I think these machines are pretty precise. Okay, now we're skipping the interpret for the moment. Just for the moment. Yes, honey. We're gonna do it at the end, so I would just not leave lines. You don't have to leave any lines. It'll be there. Um, So in this problem, we have a little bit of translating to do. So we need to translate the word. So this is not our usual. Usually it just says greater than or less than or something like that. This one says within 0.25 ounces of the true difference in means. Okay, so let me ask you this. What is the true difference in means? You calculated it just a second ago. 10, right? Okay. So the true difference in means is 10. Do you know where that came from? Okay, now within means on either side of 10 by 0.25 ounces. So within means somewhere in the interval that's plus or minus 0.25 from 10. So these numbers are between 9.75 to 10.25 ounces. And now you can translate that to a normal CDF statement because you have a high and a low. Or should I say a low and a high? Okay. You notice Mrs. Talbot's throwing in all the critical thinkings. Did inverse norm yesterday. Standard deviation was 0.205. And again, we've already labeled everything. This is kind of a satisfying answer, especially if you're me. Maybe if you know me well enough, you'll know why. It's just satisfying on a slot machine. Okay. So, okay. Now, that's it for the actual lesson minus this. So the last thing is interpretation challenge. I want you to, in your groups, try your best to figure out the interpretation sentences for the mean and the standard deviation. And after a few minutes, I'm gonna put up the perfect ones. And basically, I just want you to see how many of the elements of them that you can get on your own. I'm gonna freeze the screen so that I can write it nice. Do you guys know what you're supposed to be doing? it's like, over the, yeah, so they, I only have one that, you know, transfer that I got. So it's really not different, so. It's very familiar. All right, sounds like most of you are done except for the group that did nothing. So here's the answers. For the mean, over many random samples of 20 large and 25 medium drinks, the difference in liquid dispense, and this is where I'm gonna predict that you forgot to put the order of subtraction, large minus medium, is 10 ounces on average. Now, you could say the average difference in liquid dispensed instead, that's totally fine. So you could put the word average in front of difference, or you could put it at the end. I don't care, as long as average is in there somewhere. Okay, standard deviation, which might actually be easier because we practiced that more. Over many random samples of 20 large drinks and 25 medium drinks, the difference in liquid dispense, large minus medium, typically varies from the mean of 10 ounces by 0.205. How did we do? I heard a lot of really good stuff. I heard most of it. The only thing I didn't hear was the large minus medium when I was eavesdropping. And why do you have to do that? Because medium minus large would be a very different thing than large minus medium. You would expect that to be negative, right? Because mediums are smaller drinks. Okay. Once you get that written down, that's it, except for my, I love you butt talk. If you've had my class before, you're very used to the I love you butt talk. Yeah. So, you guys have only 5 homework problems. This is why I'm giving you the I love you butt talk. And, I'm gonna hit pause on this before I, say anything more.